In this lesson, we're going to talk about polynomials, what kind of names they have, what is important vocabulary, and then also how we evaluate them. Two important key vocabulary terms is degree and terms. Degree is the highest exponent in a polynomial, and the terms is the number of things being added or subtracted. Let's go over some names based upon terms. So the word monomial, beginning with mono, means one. Even though the example 3x squared looks like it has more than one piece, it is one thing not being added or subtracted to anything else. So it is a monomial. Binomial, bi meaning two terms. In the example, we see the first term is 4x, and the second is negative 2. This has two terms. Last one is trinomial. Tri meaning three. Here the first term is negative 2x squared. The second term is positive x, and the last term is negative 2. Three terms, trinomial. Polynomials also have names based upon the highest degree you see. If ever you have something with degrees, you're always looking at what is next to the x. Okay? The degree is always in front of the x. Sorry, is always the exponent on the x. Don't ever look at any exponents, any numbers, because those can just be worked out. So if something has an x to the power of 0, well, we know that x to the power of 0 is 1, so that means you wouldn't actually see the x at all. So that would be a constant. But if you had something with an x, with just an x, its exponent usually isn't written, but it is a 1, so it is called linear. If you have a polynomial with x squared power 2, it's a quadratic. If you have x to the power of 3, that's cubic. X to the power of 4 is quartic. And x to the power of 5 is quintic. So take a look at these couple examples. The highest exponent I see is 3. There are two exponents. There is a 3 and a 1, but we only care about the highest one we see, 3, making this cubic. How many terms are there? 1, 2, 3 things being added together, so it is a trinomial. In the second example, there are also still two exponents, a 2 and a 1, but we only care about the highest one we see, which is 2, making this quadratic. It has 2 pieces, so it is a binomial. A quadratic binomial. Now sometimes we're not ready to actually look and name things because they're not in standard form. Standard form polynomials are always written from highest to lowest based upon the powers. In order to do that for the first example, we're going to have to combine like terms. The first like terms I see is a 4x and a negative 4x. The next set I see is a plus x squared and plus 2x squared. The last two terms have a 4 and a 3 for their power, so they are not like terms. So let's go ahead and start combining and ordering. First up is the highest power, the power of 4, so negative 2x to the 4th power. Next is power of 3, there's a positive 3x to the 3rd power. Now our x squares, we have 1 and 2 together make 3x squared. And then lucky for me, 4x and negative 4x make 0, so those go away. The highest power I see is 4, so this is a quartic. And it has 3 pieces, so it is a trinomial. a quartic trinomial. Sometimes polynomials aren't actually multiplied out yet. To see the powers, we're going to actually have to start out by FOILing. So first, 9x squared, outside, negative 6x, inside, plus 6x, last, minus 4x. Negative 6 and positive 6 make 0, so those are gone. Don't forget, we have a 6x still on the outside, so let's distribute it. 54x for 6 times 9. Power 1, power 2 makes power 3. Negative 4 times 6 is negative 24, and the 6 brings an x. Highest power I see is 3, so this is cubic. There are 2 terms, so it is a binomial. Now it's time to see some ways to evaluate polynomials. Now there's an old-fashioned way of doing this, and that is taking the 3 and plugging it into all the x's in the problem. Polynomials sometimes have pretty large exponents. Also, depending upon the number you're plugging in, doing the exponents could be pretty complicated or laborious. So we have another way to do this. It's called synthetic substitution. The way that we do synthetic substitution looks like this. We draw this little pattern like this. Next, we put the 3, which is the x that we're plugging in, and then we're going to write down all the coefficients from the problem. The first coefficient I see is 2, and that comes from looking in front of the x to the 4th power. Next is the x to the 3rd power. I don't see it, so I put 0. Again, that's because I'm looking for x to the 3rd power. Next up is x to the 2nd power. I do see that. That's negative 8. Next up is x to the power 1. That would be the number in front of x, positive 5. And then lastly, the negative 7. X to the power 0 is always 1, so it's always the number that doesn't have an x on it. So here's the way this pattern and this process works. We are going to multiply by this onto this row, and each of the steps are going to be some adding going straight down. Okay? So in the first column there's nothing to be added down, so I'm just going to add the 2 and bring it straight down. Oops, sorry about that. Now it's 3 times 2 will bring me and give me another number to add. 3 times 2 is 6. Now it's time to add straight down, and we get 0 plus 6 is still 6. Now here comes the part where we will mess up. Some people want to do 2 times 6. No, it's still the 3. 3 times 6. 3 times 6 is 18. And now it's time to add straight down. Negative 8 plus 18 is 10. Now multiply by 3. And you get 30. And then add straight down. 35. Then multiply by 3. $105. and then add straight down. 98. So that answer at the very end, 98, is your actual answer. When you plug in 3 into the function, into the polynomial, you actually get 98. This is your answer. Let's try that one more time. So again, we draw that boxy looking thing. We put what x is equal to over here, -2. Now we're going to list out all the coefficients, the numbers in front of the x's. The highest degree I see in this polynomial is power of 5. Its coefficient is 3. Then after 5 is power of 4. That coefficient is -4. Then power of 3, I don't see it, 0. Power of 2, I don't see it, 0. Power of 1, that's the -5. Power of nothing, that'd be the 10. Again, we're looking at the numbers in front of each of these things. Power of 5, power of 4, power of 3, power of 2, power of 1, power of 0. Remember, we are multiplying 2 by whatever numbers come down here, and we are adding straight down. To get a number to multiply, let's bring down the 3. So 3. -2 times 3 gives me -6. Now it's time to add straight down. -4 plus -6 is -10. Now we multiply by -2 again. -2 times -10 is +20. Now we add down. 0 plus 20 is still 20. Now we multiply up. -2 times 20 is -40. Now we add down. 0 plus -40 is still -40. Again, multiply by -2 up, and you get +80. Add down, and you get 75. Then again, multiply by -2 up, and you get -150. And then the last thing is to add down, and you get -140. So there you go, that number at the very end is our answer. So when you plug in 2 into that function up there, you get -140. Okay, as always, if you have any questions, go ahead and leave comments, and I'll see you in class.